So, in today's class, we have seen a few good number of topics, right? A good number of questions, in fact. We started with this question where we have understood some correlation between bulk modulus and pressure, right? After this, we came on to the next question where we have taken up that a cylinder is rotating, right? A cylinder is rotating about its axis, and we had to find out how much is the difference that comes between its center point and the edges, right? This height we had to find out, and we proceeded with the question. Post which we had a question where we were told that a solid object is falling down in a liquid, and we had to find out what is the instantaneous power proportional to, which power of radius is the instantaneous power proportional to. So it is proportional to the fifth power of radius. See here, right? Then we saw a question where we had to talk about the relative density of oil. We had a solid object floating in liquid. Its submerged volume was given by V by 4, sorry, 4V by 5. Then we poured some oil into it, after which we were told that it is equally submerged in both the liquids. We needed to find out what's the ratio between density of oil and density of water. So all we did is we understood the concept of buoyancy, what's buoyant force equal to, and in both cases by this principle that for any floating object, the net force is zero. By this principle, we understood, or we applied this principle and took the net force as zero in both cases in order to find out the ratio of density of oil and density of water, right? After which we have next question where we have a hole at the bottom of the vessel. Height of water is 20 meters. We are supposed to find out what is the efflux velocity. This is the question. What is the efflux velocity? This is the question from IEEE 2004, right? And all we did is we found out the efflux velocity is under root 2gh by using Bernoulli's theorem, right? Bernoulli's equation. And accordingly, after substituting the values, you'll get the answer as 20 meter per second. Now, next question was, you have a solid object which is falling in a liquid. You were given the value of viscous force and asked to find out what is terminal velocity. Okay. So again, whenever we have velocity becoming equal to terminal velocity, at that point, the net force on that object is zero, right? You substitute it and get the answer of terminal velocity. This is the question. This is the working. This is the concept. Then we came to one more question where you had a cylinder which was suspended from a spring. The extension of the spring is x naught. You were given that half of it is submerged in a liquid which has density sigma, You were supposed to find out what is this extension x naught. You were supposed to find out what is this extension x naught. So we learned that there is, in this question, in such kind of questions, a very simple approach. First, draw the FBD, right? That is free body diagram. Show that in which direction forces are acting and what all forces are acting on the body. Step 1. Step 2. Equate the net force on the system equal to mass into acceleration from Newton's second law, right? If it's given that the system is in equilibrium, then you can take F net as 0, right? As soon as you do it, you will get an expression in terms of forces acting on the body, right? Then you just solve in order to get the required variable. For our case, the required variable was x naught. So you'll be able to get x naught value this way, right? So this is all about it, right? Any queries, any questions, you can put in the comment box and let me know, right? We can deal with the queries, or maybe we can take up a class where we'll discuss these questions, right? Feel free to let me know. Thank you very much. Thank you, class. Thanks a lot. In the coming classes, we are starting with the syllabus for class 12th, and we'll be taking, let's start with class 12th, and we'll be taking dual nature of radiation and matter, atoms and nuclei, and semiconductors, right? Thank you. Thanks a lot. All. Thank you.